This video shows the Doppler response of blood flow in the retinal vessels in the optic disc region of a volunteer. The pulse wave in arteries creates strong blood flow variations during the cardiac cycle. These images were made by digital hologram rendering from optical interferograms recorded with an ultra-high-speed camera at 67,000 frames per second. That composite color version of the same video shows the local Doppler broadening. A diversity of measurements can be computed afterwards from the same interferometric data, such as the asymmetry of the Doppler spectrum here, which reveals blood flow in the lumen of the out-of-plane vessels, namely the central artery and vein. The major limitation of this technique is the requirement of an ultra-high-speed camera to record optical fluctuations with a sufficient bandwidth. But that can be circumvented by leveraging slower streaming cameras that can be used for real-time holographic imaging with the Holovibes software, which can handle robust image rendering and processing. Here you can see the video footage that can currently be computed in real time with commodity computer hardware and a streaming camera at a sampling rate of 2000 frames per second. Yet the variations of blood flow during cardiac cycles are difficult to spot. To enhance their visualization, some signal processing can be performed with Holovibes. Each image is divided by a blood version of itself in order to flatten static image contributions. That creates this kind of output that better reveals small signal variations in retinal vessels. The signal washout due to local dispersion outside the detection bandwidth of the streaming camera, that's a consequence of higher local dynamics, can now be revealed by reversing the contrast of the previous processed image. Real-time Doppler holography with streaming cameras will predictably be enhanced in the near future according to Moore's law, because data throughput and computational power are the only requirements to enable non-invasive angiography with this approach.